My name is Ismael. For those of you who don't know, I am one of the co-founders of Lagrange Labs. Lagrange Labs is a ZK proof company. We're not a ZK rollup company. We're not a ZK VM. We're not a ZK ML company. What we are is a company that specializes in the generation of zero-knowledge proofs across a wide variety of verticals. So today what we're going to talk about is the state of ZK proving and where it's headed. So Lagrange focuses on something called decentralized proof generation for all of our products. And what decentralized proof generation is taking the highest security form of computation, verifiable computation, and running it in a way that confers liveness and censorship-resistant properties. In short, making ZK something that is decentralized and aligns with the ethos of our space. The current generation of ZK proof generation is centralized, limited scale, high cost structure, and dependent on a small subset of cloud providers and operators. If you interact with a ZK rollup today, you're transacting on an execution space proven by a single party. If tomorrow Google decides that they don't like the privacy properties of a major ZK rollup company, they can censor it. They can shut it off. Not really the reason that we entered this space. Decentralized proving removes these constraints. It makes blockchains, zero-knowledge blockchains, operate the way they should. So how does decentralized proving work? Well, you effectively have a point in the stack where you want to generate a proof for some application. Assume, for example, you want to do proof generation for a coprocessor or for a ZK rollup. What you want is for the person generating that proof to have a decentralized generation. What you want is there to be a market or a network dynamic under which there are competitive impacts on price and competitive impacts on liveness. And so this is what Lagrange does. We have what we call the Lagrange Prover Network, which is a modular, highly scalable, and decentralized substrate for generating zero-knowledge proofs for our applications and our customer applications. The Lagrange Prover Network is structured with what we call subnetworks, or modular containers or independent markets under which work is assigned across our operators generating proofs. And what this allows us to do is to have a network that scales horizontally with small subnetworks focusing on the generation of proofs for different domains. We have a subnetwork for our work with ZKsync. We have a subnetwork for our work with other rollup teams. We have a subnetwork for our work with our coprocessor, and we have a subnetwork for work with other products that we're releasing very soon that touch on AI x crypto. And so you can very easily spin up one of these networks, tap into a large set of operators, people like Coinbase, Kraken, OKX who run our provers, and you can be in production with high liveness decentralized proving today with Lagrange. And so how does this work from start to finish? Well, very simply, you can think of this like an order book or an auction. Think of Binance or Hyperliquid, but for the generation of proofs. You express price preferences, how much you want to pay for a proof, and that work is assigned to the network. It is assigned to an auction or double auction wherein people who have latent compute resources, GPUs or VPUs or any other application-specific hardware, bid on the generation of that proof. And they express their price preference over that generation, and our auction mechanism matches bidders and proof requesters such that we can have an efficient market for the generation. If someone generates their proof on time, or an operator generates the proof on time, they receive a payment and a reward. If they fail to, they are slashed. Now, why did we opt into this architecture and what are the benefits? Scale, right? If every application is going to be a ZK application in the future, what you need is a network that can generate those proofs at a sufficient throughput. Having a single auction that tries to match every single incoming proof request to a group of provers isn't going to scale. What you need is modular independent subnetworks that we call gateways. Each of these has a dedicated pool of provers that generate proofs for those circuit types and can scale horizontally, which lets us have dynamically scalable, decentralized proving for all of our counterparties and customers. And so what powers this is a novel double auction mechanism called DARA, developed by our team. One of the things that Lagrange prides itself on is being one of the few companies in the space that actively pursues fundamental research and publishes fundamental research alongside commercializing products. So DARA is the first paper covering mechanism design for prover markets, and it was accepted into one of the top conferences in the space, Financial Crypto 2025. We did a talk on this earlier today, so I'll spare everyone all of the details, but you can think about it very simply as a mechanism to match buyers who want to generate proofs and sellers who are selling compute on this network. And what this allows us to do is to present a set of properties and enforce a set of properties that we consider incentive compatible. Things like collusion resistance, right? Provers aren't colluding in order to drive up price. Things like computational efficiency, things like welfare maximization, budget balancing, all of the properties that you want in a TFM, we can enforce on a network doing proof generation. And what this lets us do is do universal proving on our network, right? Lagrange builds a ZK coprocessor that does SQL computation. We work with teams like ZKsync and Polygon stack chains through our work with Caldera and AltLayer. And that means that we have to support a very broad set of proof generation requirements. And we do that through this universal property of how our network can scale horizontally. Now, let's cover a case study of some recent work that Lagrange did with one of our partners, ZKsync. We announced that a large subset of the elastic chain, we believe, will be proven on Lagrange in the future. And we've launched a portion of our network dedicated to the proving of ZK stack chains. And so this is the industry's first deployment. This is live today with operators including Coinbase, P2P, Blacksand, Impstones, etc. And it's actually generating proofs for real batches for ZKsync elastic chains. It's on a test net, so these batches aren't being used as part of ZKsync's core mechanism, but what this proved out was that this thesis is possible. You can have comparable performance with a substantial reduction in cost by enforcing market dynamics on how proof generation occurs. So this network was launched. It's been live about a month at this point, and we expect a lot more stuff touching this very soon. Now, what's next for Lagrange's prover network? We announced recently a number of major partnerships with ZKsync, with rollup as a service providers, teams like AltLayer and Caldera, as well as some great work expanding out the types of proving systems that our network supports. We expect very soon to have other types of proving backends and other types of ZK VMs on our network, obviously constrained by the demand for ZK in space, but we see a lot of that gravitating towards generality. There is also some great work that's coming at the intersection of ZK and AI that Lagrange will be pushing out very soon. I can't go into all the details today, but what we kind of want to present as an early concept is why this matters, right? It's often hard to anticipate the size of the market for AI, right? What's the TAM for AGI or ASI? Well, if you think of the GDP of humanity as about 100 trillion, conservatively, ZK should be, or AI should be able to increase that by maybe 2x, 3x by automating the majority of intellectual work. Well, in that case, you're talking about 200 to 300 trillion in market size. And in that case, you must ensure that there's the correct constraints in place such that any type of intelligence system that's deployed has guardrails over its function. ZK and crypto in general serve as a great way to build high liveness systems, but enforcing computational constraints on top of that is best done through ZK. And so We expect that ZKML is going to be a very important component of ensuring that AI systems can safely and effectively scale. And we have a lot more to share on this very soon. And now, as a final takeaway, I want to say, we like to say prove everything with Lagrange. Really, whatever you're building, all the way from a coprocessor to a ZK rollup, can be proven on Lagrange. It's universal, it's decentralized, it enforces properties, and incentive-compatible properties over how work is assigned and pricing is handled. And it's run by some of the top institutional operators in the space. People like Coinbase, Blacksand, Impstones, Kiln, P2P, Hashkey, top exchanges participate in generating proofs on Lagrange today. If you want to run a prover, contact us, and you're more than welcome to. And if you want proofs for any place in your application, also contact us, and we should be able to provide this for you. So thank you all for joining me today. And yeah, reach out.